Theorem. In the ring Zn, the divisors of 0 are those elements which are not relatively prime to n. This is the set Zn. Let m is an element of Zn and m is not equal to 0. We have two things. When m is relatively prime to n and when m is not relatively prime to n. M is relatively prime to n, m is not a zero divisor of Zn. When m is not relatively prime to n, m is a zero divisor of Zn. Let m is not relatively prime to n. Then GCD of m and n is equals to some element which is greater than 1, because if two numbers relatively prime, then GCD is equals to 1. So D divides m and D divides n, or m divided by D and n divides by D. Consider m divided by D times n, that is equals to 0. That's because the multiples of Zn are 0 because of the modulo n. Then replace D as the denominator of n, and that is also equals to 0. That implies m is an element of Zn, n divides D is an element of Zn, and n divides D is not equals to 0, and also we know m is not equals to 0. Hence, we can say m is a zero divisor of Zn. Now, we proved when m is not relatively prime to n. Let's prove when m is relatively prime to n. Suppose m is relatively prime to n. Then GCD of m and n is equals to 1. We must show m is not a zero divisor of Zn. Let m be a zero divisor of Zn. Then there exists T, an element of Zn, such that m into T is equals to 0 where T is not equals to 0. Then by Euclid lemma, n divides the product of m times T. That's because if any product gives 0 as the final answer of Z modulo n, that is a multiple of n. Since the GCD of m and n is equals to 1, n does not divide m. Therefore, n must divide T. That means T is equals to 0, and that is a contradiction because we suppose T is not equals to 0. Hence, m is not a zero divisor of Zn. So we proved the ring Zn contains zero divisors which are not relatively prime to n.